Okay. Alright. Did I stream yesterday? I did. I just did resume stuff, okay. I had to do some annoying transfers of, well, whatever, that doesn't matter. But that's why the stream is late. What is it, 3:30? Yeah. I got stuck with some GPG, credential backup management, transferring over of 2FA tokens, and a whole bunch of things like that. But that's all set and figured out. So now, let's see. Okay. See what I'm gonna do. I think I'm gonna skip the config management section. I just don't think I really need to do this puppet thing, and I don't really feel like learning this right now, especially since I don't really need it for the time being, and so it's just gonna be kind of taking up time for something I don't really want to do. At the end of the day, it's just creating a manifest file using Puppet, which is going to be their own syntax, and then uploading it. So I'm just going to skip this one entirely, and I'm going to go straight to networking services. Here we go. Actually, I could turn this on. I'm going to go straight to this instead. Okay, this is going to be important. Okay, you'll learn how to link your systems. Okay, let's just watch this and see.
Welcome to Module 3. In this module, you'll learn all about how to link your systems up using a variety of networking tools and protocols. First, we'll discuss the OSI 7-layer networking model and how each layer impacts your system. Then, we'll look at how to configure various networking options in both Windows and Linux. Following that, you'll learn how to configure a DNS and DHCP server using Ubuntu and connect your VMs to those services to make sure they are working properly. Finally, you'll gain some experience working with some networking troubleshooting tools, and you'll use those to explore a few networking protocols such as HTTP and SNMP. The lab assignment will instruct you to configure remote access for the VMs you've already created, as well as set up a new Linux VM to act as a DNS and DHCP server for your growing enterprise. Finally, you'll get some hands-on experience with the SNMP protocol and Wireshark while performing some simple network monitoring. This module helps build the foundation needed for the next module, which will cover setting up centralized directory and authentication systems in both Windows and Ubuntu. A deep understanding of networking is also crucial to later modules dealing with the cloud, as the cloud itself is primarily accessed via a network connection. Click the next button below to continue to the next page, which introduces the OSI 7-layer networking model.
It's always good to get a refresher. I mean, I basically know this stuff, but if you don't use it every day, you forget.
Before we start working with networking on our virtual machines, let's take a few minutes to discuss some fundamental concepts in computer networking. For most people, a computer network represents a single entity connecting their personal computer to the internet, and not much thought is given to how it works. In fact, many users believe that there is a direct line from their computer directly to the computer they are talking with. While that view isn't incorrect, it is definitely incomplete. A computer network more closely resembles this diagram. Here we have 3 computers connected by 6 different network devices. The devices themselves are also interconnected, giving this network a high level of redundancy. To get from computer A to computer B, there are several possible paths that could be taken, such as this one. If at any time one of those network links goes down, the network can use a different path to try and reach the desired endpoint. This is all due to the fact that computer networks use the technology called packet switching. Instead of each computer talking directly with one another, as you do when you make a long-distance phone call, the messages sent between 2 computers can be broken into packets and then distributed across the network. Each packet is able to make its way from the sender to the receiver, where they are reassembled into the correct message. A great analogy for this process is sending a postcard through the mail. The postal service uses the address on the postcard to get it from you to its destination, but the path taken may change each time. At each step along the way, the post office determines what the best next step would be, hopefully getting your postcard closer to the correct destination each time. This allows your postcard to get where it needs to go, without anyone ever trying to determine the entire route beforehand. When we scale this up to the size of the internet visualized here, it is really easy to see why this is very important. By using packet switching, a message can get from one end of the internet to the other without needing to take the time to figure out the entire path beforehand. It can simply move from one router to another, each time taking the most logical step toward its destination. Modern computer networks use a theoretical model called the Open Systems Interconnection, or OSI model, commonly referred to as the OSI 7-layer model, to determine how each part of the network functions. For system administrators, this model is very helpful as it allows us to understand what different parts of the network should be doing without worrying too much about the underlying technologies making it happen. In this module, we'll look at each layer of this model in detail. When an application wants to communicate across a network, it generates a data packet starting at layer 7, the application layer, on the computer it is sending from. Then the packet moves downward through the layers, with each layer adding a bit of information to the packet. Once it reaches the bottom layer, it will be transmitted to the first hop on the network, usually your home router. The router will then examine the packet to determine where it needs to go. It can usually do so by peeling back the layers a bit, usually to layer 3, the network layer, which contains the IP address of the destination. Then it will send its packet on its way to the next hop. Once it is received by the destination computer, it will move the packet back up the layers, with each one peeling off a little bit of information. Finally, the packet will be received by the destination application. As we discussed, each layer adds a bit of information to the packet as it moves down from the application layer towards the physical layer. This is called encapsulation. To help understand this, we can return to the postal service analogy from earlier. Let's say you want to send someone a letter. You can write the letter to represent the packet of data you'd like to send, then place it in a fancy envelope with the name of the recipient on it. Then you'll place that envelope in a mailing envelope and put the mailing address of the recipient on the outside. This is effectively encapsulating your letter, with each layer adding information about where it is destined. Then the postal service might add a barcode to your letter and place it in a large box with other letters headed to the same destination, further encapsulating it. Once it reaches the destination, each layer will be removed, slowly revealing the letter inside. In this video, we'll discuss the bottom two layers of the model, the physical and data link layers. Later videos will discuss the other layers in much more detail. First, the physical layer. This layer represents the individual bytes being sent across the network, one bit at a time. Typically, it's one device and is usually stored in the hardware itself. The network determines the best path to get from one point to another on the network. It is also the port on that bridge in the direction of the root bridge is labeled as the root port, or RP, in this diagram. Then, in the real world, VLANs are used extensively here at K-State. For example, all of the wireless access points are on the same VLAN, even though they are spread across campus. The same goes for any credit card terminals, since they must be protected from malicious users attempting to listen for credit card numbers on the network. Most enterprise-level network routers are able to create VLANs, but many home routers do not support that feature. Since we won't be working with very large networks in this course, we make use of them. In this video, I'll discuss how the network layer of the 7-layer OSI model works. The network layer is used to route packets from one host to another via a network. Typically, most modern networks today use the Internet Protocol, or IP, to perform this task, though there are many other protocols available. In addition to computers, most routers also perform tasks at layer 3, since they need to be able to read and work with address information contained in network packets. For most of the Internet's history, the network layer used Internet Protocol version 4, commonly known as IPv4. This slide gives the packet structure of IPv4, showing the information that it adds to each packet that goes through that layer. The most important information is the source and destination IP address, giving the unique address on the network for the sender and intended recipient of this packet of information. Let's take a closer look at IP addresses, as they are a very important part of understanding how a computer network works. For IPv4, an IP address consists of a 32-bit binary number, giving that host's unique identifier on the network. No two computers can share the same IP address on the same network. In most cases, the IP address is represented in dot decimal notation. Here's an example of that notation. In this example, the binary number 10101100 is represented as the decimal number 172 in the first part of the IP address. Each block of 8 bits, or 1 byte, is represented by the corresponding decimal number, separated by a dot or period. This makes the address much easier to remember, almost like a phone number. In fact, on the early days of the internet, that is exactly how it was set up. The early internet used a form of routing called classful networking to determine how IP addresses were divided. The type of network was determined by the first 4 bits of the IP address, much like an area code in modern phone numbers. There were several classes of networks, each of various sizes. When an organization wanted to connect to the internet, they would register to receive a block of network addresses for their use. For a large network, such as IBM, they may receive an entire Class A network, whereas smaller organizations would receive a smaller Class B or Class C network. So, for a Class A network, the IP address would consist of the prefix 0, followed by 7 bits identifying the network. Then, the remaining 24 bits would identify the host on the network, usually assigned by the network's owner. This helps standardize which parts of the IP address denoted the owner of the network, and which part denoted the unique computer on that network. For example, in this system, K-State would have the Class B network with the prefix 129.130. You can even see some of this structure in this map of the IPv4 internet address space created by XKCD from several years ago. Many of the low-numbered IP addresses blocks are assigned to a specific organization, representing the Class A networks those organizations had in the early days of the internet. However, as the internet grew larger, this proved to be very inefficient. For example, many organizations did not use up all of their IP address space, leading to a large number of addresses that were unused, yet unavailable for others to use. So, in the early 1990s, the internet switched to a new method of addressing called classless interdomain routing, or CIDR, sometimes pronounced as CIDR. Instead of dividing the IPv4 address space into equal-sized chunks, they introduced the concept of a subnet, allowing the address space to be divided in many more flexible ways. Let's take a look at an example. Here we are given the IP address 192.168.2.130 with the accompanying subnet mask of 255.255.255.0. To determine which part of the IP address is the network part, simply look at the bits of the IP address that correspond to the leading ones in the subnet mask. If you are familiar with binary operations, you are simply performing the binary AND operation on the IP and subnet to find the network part. Similarly, for the host part, look at the part of the IP address that corresponds to the zeros in the subnet mask. This would be equivalent to performing the binary AND operation on the IP address and the inverse of the subnet mask. Here is yet another example. Here you can see that the subnet mask has changed, therefore the network and host portion of the IP address is different. In this way, organizations can choose how to divide up their allocated address space to better fit their needs. To help make this a bit simpler, you can use a special form of notation called CIDR notation to describe networks. In CIDR notation, the network is denoted by its base IP address, followed by a slash and the number of ones in the subnet mask. So, for the first example in the previous slide, the CIDR notation of that network would be 192.168.2.0/24. Since the network starts at IP address 192.168.2. Structure of the internet, you would find the first part of that IP address was assigned to MCI, a large internet service provider. Task force. There are also 3 other reserved segments which may be used address, while keeping track of the original internal IP address. Then block many years IPv4 addresses, allowing for 300, making all space, therefore a different parsing method. Now let's take a look at layer 4 of the OSI model, the transport layer. The transport layer is responsible for facilitating host-to-host communication between applications on 2 different hosts. Depending on the protocol used, it may also offer services such as reliability, flow control, sustained connections, and more. When writing a networked application, your application typically interfaces with the transport layer, creating a particular type of network socket and providing the details for creating the connection. On most computer systems today, we use either the TCP or UDP protocols at this layer, though many others exist for various uses. First, let's take a look at the Transmission Control Protocol, or TCP. It was developed in the 1980s and is really the protocol responsible for unifying the various worldwide networks into the internet we know today. TCP is a stateful protocol, meaning that it is able to maintain information about the connection between packets sent and received. It also provides many services to make it a reliable connection, from acknowledging received packets and resending missed packets and rearranging packets received out of orders, so the application gets the data in the order it was intended. Because of this, we refer to TCP as a connection-oriented protocol, since it creates a sustained connection between 2 applications running on 2 different hosts on the network. Here's a simplified version of the state diagram for TCP, showing the process for establishing and closing a connection. While we won't focus on this process in this course, you'll see packets for some of these states a bit later when we use Wireshark to collect network packets. Since TCP is a stateful protocol, it includes several pieces of information in its packet structure. The 2 most notable parts are the sequence and acknowledgement fields, which allow TCP to reorganize packets into the correct order, resend missing packets, and acknowledge packets that have been successfully received. In addition, you'll notice that it lists a source and destination port, which we'll cover shortly. The other most commonly used transport layer protocol is the User Datagram Protocol, or UDP. Unlike TCP, UDP is a stateless, unreliable protocol. Basically, when you send a packet using UDP, you are given no guarantees that it will arrive or no acknowledgement when it does. In addition, each packet sent via UDP is independent, so there is no sustained connection between 2 hosts. While that may seem to make UDP completely useless, it actually has several unique uses. For example, the Domain Name System, or DNS, uses UDP, since each DNS lookup is essentially a single packet request and response. If a request is sent and no response is received quickly enough, it can simply resend another request without the extra overhead of maintaining any state for the previous connection. Similarly, UDP is also helpful for streaming media. A single lost packet in a video stream is not going to cause much of an issue, and by the time it could be resent, it is already too old to be of use. So, by using UDP, the stream can have a much lower overhead, and as long as enough packets are received, the stream can be displayed. Since UDP is stateless, the packet structure is also much simpler. It really just includes a source and destination port, as well as a length and checksum field to help make sure the packet itself is correct. So, to quickly compare TCP and UDP, TCP is great for long, reliable connections between 2 hosts, whereas UDP is great for short bursts of data which could be lost in transit without affecting the application itself. One great way to remember these is through the 2 worst jokes in the history of computer science. Would you like to hear a TCP joke? Well, I could tell it that transport layer protocols use ports to determine which packets are destined for each application. A port is simply a virtual connection point on a host, usually managed by the networking stack inside the same computer and share the same IP address. These well-known ports are in that way, their network model. Here's the overall view of the postal service analogy we've been using. At layers 5 through 7, you would write a letter to send to someone. That works. Finally, between nodes, body concepts to connect your systems to a network.
Okay, so on this one I'm going to have to create 3. Okay, 1 Windows and 2 Ubuntu. You may reuse existing VMs. Okay, so I have them with snapshots from the end of Lab 1, or Assignment 1, I suppose. For the second Ubuntu one, I can either quickly install and configure it from scratch, use the puppet menu, or you can copy one of your. Okay, I want to figure out how to copy. If you choose to copy, follow these steps. Okay. Completely shut down the VM. Okay, it's shut down, I believe. Close VMware Workstation. Okay. Make a copy of the entire folder containing the VM. Where is that? Is that in here? Yes. Let's see, for Mac users. Okay. So this is what I'll have to do. I wonder why you have to copy the entire folder and not just a second VM. I think you said. Because they'll conflict since they have identical net. Okay. So make a copy of the entire folder. Okay. I'm just gonna do exactly as it says and see if that works. Oh, did I click compress? What am I doing? Come on. Stop. Cancel. Duplicate. There we go. Okay. You don't want this though. Now what? Open the new in VMware Works. Look for the .vmx file. Well, I have a .vmware VM file, not VMX. Gonna open it in here. Okay. When prompted, select I copied it to reinitialize the network interface. Copied it. Oh, it's automatically starting. Okay. I want to open up the library. Oh, look at that. Okay. So that's working nicely. Okay. I don't really need this. I know that it's ARM. I just want that. Server. This is going to be client. Actually, okay. So now I have a server and a client. And I need to change the host name. This is after this, okay, so I'm gonna continue with this. good with the commands on here, so I'm just gonna do the GUI way. Still kind of buggy on here. Yeah, the mouse gets kind of buggy on here, but probably network, no, sharing. Here we go. Okay, I need to change this to S, server. S for server, I suppose. What's the hostname command? There you go. That's what it is. Do I change it in here as well? Show or set the hostname. Oh, okay. Oh, there you go. Suppose I can just pause. Okay. I really do not have a good VM workflow here with my window manager, but whatever for now. Let's see. Okay, I gotta change this. Creating a new NAT virtual network configuration. Okay. Where do I go for that? Okay, maybe here. Instead of share with my Mac, VMnet 8. NAT virtual network configuration. How do I do this? Oh, add a NAT configuration, connect instead of the network adapter. Okay. Here we go. Yep, that's what I'm on. Okay. By default, Fusion Pro provides one share with my Mac configuration that uses NAT. You can add additional NAT configurations to perform actions such as turning off DHCP service or using a non-default subnet IP or subnet mask. Select VMware Settings Network, okay. Click the icon and enter administrator password. Click OK. Oh, click the lock icon. Okay. Click the plus. VMnet 2. If you want to rename a virtual network, double click the name, enter a new name, then press the return key. I'll just keep it as VMnet 2. Allow virtual machines on the network to use NAT to connect to external networks. Okay. Select allow virtual machines in this network to connect to external networks. Okay. On Big Sur host, that's not really going to matter to me. Select enable IPv6. Do I need that? Use the appropriate option to configure IPv6 prefix text box. Manual, enter it. Automatic, leave it blank. Yeah, that's good. Click the plus sign under port forwarding section for each port forwarding configuration you want to add. I don't think I want any. To connect to the host system To connect the host system to this private network, select connect the host MAC to this network. Okay. If you enabled IPv6 and want Mac hosts to use IPv6 to communicate with the virtual machines, manually add IPv6 address. I don't care for that. On Mac systems, the NAT virtual network interface does not automatically accept IPv6 address assignments. Open a terminal, enter. Okay, I don't think I care for enable IPv6. I'm just gonna turn that off. I don't need it, especially for this tiny little lab. To use local DHCP service to distribute IP addresses to virtual machines on the network, select provide addresses on this network via a DHCP. Okay. Auto-generated everything. Okay, MTU, system config. To change the subnet IP address or subnet mask, modify this. To configure jumbo frames. I don't need any of this. This was pretty straightforward. There's not really much here to configure, apply. That's it. What did I really change? What's the difference between this? Shares the IP address of the MAC on the external network. Yeah, with NAT. Whereas this virtual machine uses the configuration will use a custom network connection. Still uses NAT. So what exactly is the difference? Is it using this? And then I need to do this as well. Connect and set up the network adapter. You can connect the virtual network adapter for the virtual machine and set up the type of networking to use. Before you begin, Fusion Pro does not support bridged networking to a VPN. You can set up. Okay, select Window Virtual Machine Library. Okay, so here, okay. Select a virtual machine in the virtual machine library window and select settings. Okay, so we're gonna do this with all of them. I'll start with, I guess, this one. Settings. This is gonna be good. You see, this is a good, the reason why I like this is because I'm getting through a lot of this stuff before starting to build my actual labs. So this is a nice dipping your toes in to setting up virtual machine environments. So that was kind of like the big thing with this. So that's why I decided to do this first. And it seems to be pretty beneficial. So under removable devices, I would not have guessed that. Oh, here, removable devices, network adapter. Select the network adapter checkbox. Oh, I have to shut it down. First, resume the virtual machine. Really? Let me see. That doesn't make sense to me. Let's just see. Okay, well, it's running. So can I configure these while they're off? Bridged networking and custom. The virtual machine does not have its own IP on the external network. Virtual machine obtains a private IP from the VMware Virtual DHCP server. Bridged, and The textbook for building virtual machine labs that I was reading, that I will probably pick up after this, or pick up where I left off from after this. That explains this pretty nice details. You see various choices for bridging to one of the network interfaces on your Mac, including wireless and Ethernet. Using one of these options is the easiest way to give your virtual machine access to a network. When you select any of the network types other than auto detect, you can click System Settings, and then private to my Mac is the virtual machine is connected only to the host operating system using VPN, which is not visible outside of your Mac. That's pretty good too. And then there's custom as well. So, and then I just select this. What's in advanced options here? Network simulation. So I suppose I can just check this. I'm gonna get some water, some better water. Okay, here we go. So now I have a custom network connection. Name VMnet2, type custom subnet, IP is here. Subnet mask is here. Okay. I suppose I cannot change this while it's off. I can. So either off or running, but not suspended. Okay. So that was pretty straightforward and easy. So task 1, part A. trying to think what a good way, what would be a good way to use my VMs, because right now this is not working. Like, okay, so let's say I have this. I would want this. Okay, does this not get any smaller? No, this has a limit. I don't know what the best. The other way would be to have everything unmanaged by the window manager. And that might be a little bit easier. But I don't know if it really would be. Seems like just minimizing is the best way. What is this? Activate remote desktop. Why did this open up? How do I do this? I think there's a features in the heck. I think there's a features section. Or there used to be. You see, yeah, open SSH client. Huh. I have no idea how to enable this. Here we go. Settings. System RDP. Enable. The port. Can I change this? I cannot. So I believe the port is the registry configuration. I'm just gonna go to Google. Enable RDP on Windows. Let's just do that first to make sure. Here, learn. So I need all of the admins. Admin account and administrator. There we go. And this one already has access, okay. Bam, done. And now the second one. Using either PowerShell or registry editor. So this just edits the registry thing via PowerShell commands. And then adding it to the firewall. And then testing it. I kind of want to do the registry editor. System, probably software. No, current control set. Control terminal server. Win stations. RDP TCP. In the main pane, select port number. Bam. Right click, modify. Select a decimal. There you go. Changing it. We want to change it to 34, 5, 6, 7. 34, 5, 6. It's not working. 34, 5, 6, 7. Okay. And that was weird. 34, 5, 6, 7. 34, 5, 6, 7. Okay. Changed. Right here. 34, 5, 6, 7. Hexadecimal and decimal. Okay. Easy enough. And then restart. Oh, and then we gotta do this as well. With advanced security? Why is this opening up? Is there, where can I find log on items? Log on. I don't think this is it. System? Startup maybe? Startup apps. Off. 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 Why is Brave? Oh, maybe it was Firefox actually. Okay. That's fixed. Here we go. We want an inbound rule, right? New rule. I'm gonna do a port one. Is RDP TCP? I think it is. RDP TCP in and UDP. Okay, I don't want to do both. 34, 5, 6, 7 was the port. Gonna allow it. Just gonna allow it. What does program do? Program path. Remote. Yeah, nah. Okay. Okay, test it on Ramina. Let's go. Let's test this bad boy. Wait, I don't want to suspend it. I want it to... Wait, no, it does need to be suspended. I don't know. Let's just see what happens if I have it running. And then I start up this. Let's just start this one. Oh no, this is not. This is not. Completely. Window is not. There we go. That's a little bit better. Okay. Do I have Ramina installed? Do not. Oh, App Center here, Ramina. Remote desktop client. Install. Why are you not? Oh, I see. It's under 100 megabytes. Oh, okay, there we go. Just gonna ignore that for now. Suppose I just connect directly right here to the IP of the Windows machine. On the port. I think I have to log out actually. This is not working. I think it's got the wrong IP. The network should be using a 172 network, should it not? Yes. So I need to rerun this. Here we go. It's gonna kick me out, depending on which user I sign into actually. I'll just sign out. I can just check from here, click this, and see the IP. Yeah, that was kind of dumb of me, I knew that. .62.12. Here we go. So we're gonna log in as I don't know what the domain is. I'm just gonna click OK. It's working. Don't know what's going on with this. That's not what I wanted. Here we go. I thought capital O added a line all the way to the bottom, but I guess not. This process seems to be hung. I don't know why. Why is that, why is it hung? Could not resolve the host name. Oh, I see. I'm doing the wrong syntax. Okay. That's why it's probably hung. So let me specify the port. Connection refused. Connection refused. I think I have to restart the firewall. Oh, I might not have it started also. I don't know. No, I did start it. Let me do this. Sudo system control status SSH authenticate. Active running. Ooh, it's on the wrong port though. Why is it on the wrong port? Why is this not updating? Active disabled. Stop. Okay. There we go. Okay. So I just never restarted it appropriately. Now let's try. Here we go. Awesome. SSH is working. Exit. On the server, set up a static IP address. Oh, I can just edit this? Okay. What does he want it? To 4.1. Okay, that's not working. Manual. Oh, address here. .16.62.41. Should be standard. And this should be what's the default gateway? Should I just have it on automatic? Can I just keep it as that? The IP address has completely disappeared. Let's read this just in case. I do not want to use net plan. I gotta configure DNS bind? Oof, I think that's not gonna be fun. why this is doing that. This is like wanting to do this, so I'm just gonna shut it, restart it, I guess. Is there no restart? I should probably check SSH one more time. Now that I configured the static IP. So let me this time try it on a Windows VM. Okay, is this gonna work? There we go. Let's see. PowerShell. Can you even, do I need WSL for this? Okay, it is showing the correct IP. Hold on, I gotta add a port. Which user? We're gonna do CIS 527. .62.41. Okay, let's see. Oh, it looks like it's working. Oh, it's working beautifully. Beautifully, it's working. It's actually working better than the Ubuntu to Ubuntu. Okay, exit. Perfect. Awesome. Okay, that's great. Now, okay, but I gotta figure out why this is not working. So I'm gonna go in here. I'm gonna open up Firefox. I'm thinking there's like the network in general is not working. Firefox doesn't even want to open. Here we go. Okay, well, it is working. What is up with all of this? Let me... I need to change all this. I don't want to see any of this. Get this all off of here. There we go. What's a random site I can go for? Let me just go to my site. There we go. Whoa, the book is a different color on here. That's kind of cool. Cool. Okay, so network connection is working. I'm not sure why. I don't know why the repos are not working anymore. Let me do this. Silent allow. Okay, now this is working. So let me try sudo apt install bind 9-y. Okay, it was also the firewall. I don't know why. Or it's not, or I just restarted and now it's working, so whatever, I don't know. Maybe I had to restart it for the DNS change configuration, but... Or... Did I change DNS? Yeah, I did. Sort of. I changed IP address information. So, okay, everything seems to be working nicely now. I think I want to take a snapshot before I start messing with bind. Is this the server? Yeah, I'm on the server, okay. I want a new one. Lab 3 before DNS bind 9 config. This is the state of the machine before configuring DNS bind 9. It is installed. Take. Ooh, okay, I see. It's just gonna be like a vertical thing. It's pretty neat. Very neat, actually. I don't even have to shut down the machine for that. It just, boom, snapshot. Actually, you want to shut it down. So let me do that. I think that's what you're supposed to do. Here we go. Okay, I'm gonna delete this snapshot. Now I want to take a. Now I want it when it's off. So lab 3 before DNS bind 9 config. This is taken with DNS bind 9 installed, but prior to any config changes. Take. Okay. There we go. I would at least like to finish this entire section. Core networking services. Oh, I should probably watch these. Yeah, before moving on.
Now, let's look at how to manage and configure a network connection in Windows 10. To begin, I'm working in the Windows 10 VM I created for Lab 2 with the Puppet manifest files already applied. First, let's take a quick look at how our networking is configured in VMware. This will be very important as you complete Lab 3. To view the virtual networks in VMware Workstation, click the Edit menu and then choose Virtual Network Editor. On VMware Fusion, you can find this by going to the VMware Fusion menu, selecting Preferences, and then the Network option. Here, you can see the virtual networks available on your system. Right now, there are 2 networks on my system, one host-only network and one NAT network. For this lab, we'll be working with the NAT network, so let's select it. First, let's look at the network type listed here. For this module, it is very important to confirm that the network type is set to NAT and not bridged. If you use a bridged network for this lab, you could easily break the network that your host computer is connected to, and in the worst case, earn yourself a visit from K-State IT staff as they try to diagnose the problem. So, make sure it is set correctly here. We can also see lots of information about the network settings. For example, we can see the subnet IP and the subnet mask here. By clicking on the NAT settings button, I can also find the gateway IP. The gateway IP is the IP of the router, which tells your system where to direct outgoing internet traffic. You'll want to make a note of all 3 of these, as we'll need them later to set a static IP address. You can also click the DHCP settings button to view the settings for the DHCP server, including the range of IP addresses it uses, which can also be very helpful. If you want to change any of these settings, you can click the Change Settings button at the bottom. You'll need administrator privileges to make any changes. Next, let's confirm that our VM is using that virtual network. To do so, click on the VM menu and then select Settings. Then choose the Network Adapter option. Make sure that the network connection is set to NAT here as well. Okay, now let's take a look at the network connection in Windows 10. First, you can see information about the available network adapters in the Device Manager. You can access that by right-clicking the Start button and choosing Device Manager from the list. On that window, expand the section for Network Adapters. Here, you'll see that this VM has a single network adapter, a couple of Bluetooth adapters, as well as a few other devices available. Next, let's look at the network settings for our network adapter. You can find these by right-clicking on the Start button once again and choosing Network Connections, or by right-clicking the network icon in the notification area and selecting Open Network and Internet Settings. This will bring you to the Network Status window in the Settings app. While you can find quite a bit of information about your network settings here, I found it is much easier to click the option for Change Adapter Options below to get to the classic Network Connections menu on the control panel. Here, I can see all of the available network adapters on my system, as well as a bit of information about each one. Let's right-click on the Ethernet 0 adapter and select Status. This window will show you the current connection status, as well as some basic statistics. You can click the Details button to view even more information, such as your IP address and your MAC address. And default, we'll be setting a static IP on Windows 10, but you will use this process. You can also send the response ports, as well as any established connections. As you are working with network programs, this RT command will use a series of ICMP echo messages to trace the. For this lab assignment, you won't be setting a static IP on Windows 10, but you will use this process in the next module when you configure your first Windows server. The process is very similar. Windows includes a number of tools to help troubleshoot and diagnose issues with your network connection. First off, the Network Troubleshooter, available in Network and Internet Settings menu, is pretty good and can help you figure out many simple issues with your network connection. Beyond that, there are a few command line tools you should be familiar with in Windows. So let's open a PowerShell window. The first command to use is ipconfig. Earliest versions, and it can give you quite a bit of information about your network connection. Running it without additional options will give you your IP address, subnet mask, default gateway, and other basic information for each of your network adapters. You can also run ipconfig/all to see all the available information about network adapters on your system. It gives you quite a bit more information, including your MAC address and DHCP lease information. That command also allows you to manage your DHCP client. For example, if you're using DHCP, you can use ipconfig/release to release all IP addresses, then ipconfig/renew to request a new DHCP address. On this computer, since I have static IP addresses set, those commands will not do anything. This is very handy if you have recently reset or reconfigured your network router, as you can tell Windows to just request a new IP address without having to fully reboot the system. You can also use that command to help manage your DNS cache. Windows maintains a cache of all DNS requests and the responses you receive, so that multiple requests for the same DNS name can be quickly resolved without needing to query again. You can use ipconfig/display DNS to view the cache DNS entries on your system, and you can use ipconfig/flush DNS to clear the cache. This is very handy when you're trying to diagnose issues with DNS on your system. Of course, DNS caching could create a privacy concern, as the DNS cache will contain information about all websites you visited on this system. In fact, some anti-cheat programs for online video games have been found to check the Windows DNS cache, looking for entries from programs known to interfere with their games. Finally, Windows includes a couple of really handy troubleshooting tools. The first tool you can use is the ping command, which sends a simple message to any server on the menu to confirm action. For example, I'm going to ping one of Google's DNS server messages to trace the route across the internet from your computer to any other system. This will show all open ports. Includes one helpful tool called TCP View, which allows you to view all of the active TCP connections on your system. This will show all open ports as well as any established connections. As you are working with for more information about how to troubleshoot connections using these tools. The Windows sysinternal suite of tools also includes one helpful tool called TCP View, which allows you to view all of the active TCP connections on your system. This will show all open ports as well as any established connections. As you are working with network programs, you can use TCP View to get a good idea of what connections are happening on your system. It can also help you diagnose some problems with programs and your firewall configuration. You can also use the netstat command in PowerShell to find similar information, but I prefer the graphical view from TCP View to view this information. That's all for configuring Windows networking. Stay tuned for information about configuring networking. Now, let's take a look at how to manage and configure a network connection in Ubuntu 18.04. To begin, I'm working in the Ubuntu VM I created for Lab 2 with the Puppet manifest files already applied. First, let's take a quick look at how our networking is configured in VMware. This information is also covered in the video on Windows networking, but it is relevant here as well, since it will be very important as you complete Lab 3. To view the virtual networks in VMware Workstation, click the Edit menu, then choose the Virtual Network Editor. On VMware Fusion, you can find this by going to the VMware Fusion menu, selecting Preferences, then the Network option. Here, we can see the virtual networks available on your system. Right now, there are 2 networks on my system, one host-only network and one NAT network. For this lab, we'll be working with the NAT network, so let's select it. First, let's look at the network type listed here. For this module, it is very important to confirm that the network type is set to NAT and not bridged. If you use a bridged network for this lab, you could easily break the network that your host computer is connected to, and in the worst case, earn yourself a visit from K-State IT staff as they try to diagnose the problem. So make sure it is set correctly here. We can also see lots of information about the network settings. For example, we can see the subnet IP here and the subnet mask here. By clicking on the NAT settings button, I can also find the gateway IP. The gateway IP is the IP of the router, which tells your system where to direct outgoing internet traffic. You'll want to make a note of all 3 of these, as we'll need them later to set a static IP in Ubuntu. You can also click the DHCP settings button to view the settings for the DHCP server, including the range of IP addresses it uses, which can also be very helpful. If you want to change any of these settings, you can click the Change Settings button at the bottom. You'll need administrator privileges to make any changes. Next, let's confirm that our VM is using that virtual network. To do so, click the VM menu, then select Settings, then choose the Network Adapter option. Make sure the network connection is set to NAT here as well. Okay, now let's take a look at the network configuration in Ubuntu. In this video, I'll discuss how to view and update the networking settings using the GUI. There are, of course, many ways to edit configuration files on the terminal to accomplish these tasks as well. However, I found that the desktop version of Ubuntu works best if you stick with the GUI tools. You can access the network settings by clicking the Activities button and searching for Settings, then selecting the networking option on that window. As with Windows, you can also right-click the networking icon in the notification area and select the network connection you wish to change and choosing the appropriate settings option in that menu. Once in the settings menu, click the gear icon next to the connection you'd like to configure. The Details tab will show you the details of the current connection, including the IP address, MAC address, default gateway, and any DNS servers. On the Identity tab, you'll see that you can edit the name of the connection as well as the MAC address. To change the network default gateway, click the gear icon next to the connection you'd like to configure. The Details tab will show you the details of the current connection, including the IP address, MAC address, default gateway, and any DNS servers. On the Identity tab, you'll see that you can edit the name of the connection as well as the MAC address. To change the network settings, click the IPv4 tab. Here, you can choose to input a manual IP address. If I select that option, I'll have to enter an IP address, subnet mask, and default gateway. For the IP address, I'll just make sure that it isn't in use on the network by picking one outside the DHCP range used by VMware. The subnet mask and default gateway should be the same as the ones you found in the VMware network settings earlier. Finally, we'll need to enter some DNS servers. Typically, you can just enter the same IP address as your default gateway, as most routers can also act as DNS resolvers as well. You can also use other DNS servers, such as those from OpenDNS or Google, as described in the Lab 3 assignment. Once you've made your changes, click the green Apply button in the upper right corner to apply your changes. If everything is successful, I should still be able to access the internet. Let's open a web browser just to be sure. Ubuntu includes a number of tools to help troubleshoot and diagnose issues with your network connections. Most of these are accessed via the command line. So let's open the terminal window. First, you can view the available network devices using the networkctl command. You can also view their status using networkctl status. If you've worked with commands, most of these are accessed via the command line. So let's open the terminal window. First, you can view the available network devices using the networkctl command. You can also view their status using networkctl status. If you've worked with Linux in the past, you're probably familiar with the ifconfig command. However, in recent years, it has been replaced with the new IP command, and Ubuntu 18.04 is the first LTS version of Ubuntu that doesn't include ifconfig by default. So we'll be using the newer commands in this course. The first command to use is the IP address show command. This command will show quite a bit of information about each network adapter on your system, including the IP address, which is right here. You can also find the default gateway using the command IP route show. Here we can see the default gateway. The new IP command has many powerful options that are too numerous to name here. I highly recommend reviewing some of the resources linked below the video to learn more about this powerful command. In addition, Ubuntu includes a ping command very similar to the one included in Windows. It uses the Internet Control Message Protocol, or ICMP, which allows it to send a simple echo request to the server. Most servers will respond to that request, allowing you to confirm that you are able to communicate with it properly across the internet. While it may actually seem like a very simple tool, it can be very powerful in diagnosing a troublesome internet connection. On Ubuntu, note that by default the ping command will continuously send messages until you stop the command using Control-C. If I send a few messages, then I can press Control-C to stop it. You can also specify the number of messages using the -C option. Use a series of ICMP echo messages to trace the route across the internet from your computer to any other system. This is similar to the trace RT command on Windows, located in examine TCP, short for what TCP view will show. Using just the SS command will get a list of all sockets, which is much like what TCP view will show on Windows. You can find just the listening TCP sockets by using SS-LT. As with other commands, there are many different uses for this command. Consult the resources linked below this video for more information on how to use it. With that information in hand, you should be able to complete task 2 of this lab assignment, which is to set a static IP address on your Ubuntu VM acting as the server. If you run into any issues, please post in the course discussion forums to get help. Good luck! When you are working with network connections, you'll inevitably run into some issues. Understanding how to perform basic network troubleshooting is a very important skill for any system administrator to have, and it is one that you'll find yourself using time and time again. In this video, I'm going to briefly review some of the steps that you can take to diagnose and fix network issues. As a quick side note, many of the resources linked below this video still refer to older Linux commands such as ifconfig and traceroute instead of their newer counterparts. So you may have to translate the commands a bit to get them to work on newer systems, but the process in theory itself should still apply. In addition, many of these troubleshooting tools can be blocked by restrictive firewall rules, so you'll need to be aware of your current firewall configurations and adjust as necessary. If possible, you could disable firewalls for testing, but that also could create a security concern. So make sure you keep in mind the fact that firewalls can also be the root cause of many of these symptoms. First, when faced with any unknown network issue, the very first step is to reboot any and all devices involved if possible. This includes your computer, routers, switches, modems, and any other. This includes your computer with any unknown network issue. The very first step is to reboot any and all devices involved if possible. This includes your computer, routers, switches, modems, and any other networking devices along the path between your system and the intended destination. While this may seem drastic, in many cases it could be a simple fault in the hardware or networking software that a quick reboot will fix, while diagnosing and fixing the error without a reboot may be nearly impossible. Of course, in an enterprise setting, you probably don't want to reboot your entire network infrastructure each and every time you have an issue, so you'll have to examine the trade-offs before doing so. On a home network, however, rebooting the computer and router is a pretty negligible cost. Next, I recommend determining how far across the network you can reach. In effect, this helps you pinpoint the exact root cause of the network issue, and it will tell you where to focus your efforts. This process can be performed on almost any operating system as long as it has the ping command available, as well as a command to display the current IP address. First, you'll need to determine if your computer is able to connect to itself. You can do so using the ping command to send requests to the loopback interface on your system. To do so, you would use these two commands. The first is ping and the IP address 127.0.0.1, which is the default IP address MD6. The second command pings the that's where you'll want to focus the ping command to ping yourself via that. I use the following commands. IP commands as described above. The default gateway address is this address right here. Once again, we'll use the ping command to try and reach that address. If it works, that means you're able to successfully contact your router. If not, it could be an issue with the network cables between you and your router, or a misconfiguration of either your router or static IP address. In either case, this is sometimes the most frustrating case to run on your network, that there are a couple more steps to perform here. First, if you know the public IP address and default gateway address your internet service provider or ISP is providing to you, you can try to ping those addresses. If they do not work, most likely the problem is with your network modem or your local ISP. In that case, you'll want to get in touch with them to try and resolve the issue. Next, you should try to ping a server on the internet by IP address. I usually recommend either the OpenDNS servers or the Google DNS servers. For example, I just did 8.8.8.8, which is one of the Google DNS servers. If you can, one that won't be cached on the system. I hate to say it, but using search engines other than Google, such as Bing or Yahoo.com, are all great choices for this step. When you do so, you could receive a message that it is unable to resolve that DNS name into an IP address. If that is the case, you should check your DNS settings. If nothing else, you can always replace them with settings for OpenDNS or Google DNS and test with those addresses instead. If you are able to resolve the IP address but unable to reach them, then you could have a firewall issue of some kind. It is very rare that you are able to ping servers by IP address but not via the DNS names, so a firewall is most likely the culprit here. Of course, if you're able to reach those sites correctly using ping, then the last step is to open a web browser and try to load one of those web pages. If that fails, then you'll need to examine either the browser software itself or the firewall. This is just a brief overview of some. However, this should give you a set of universal tools you can use to at least pinpoint the location of your error and narrow your search to a specific device for troubleshooting. A network monitoring program developed in 1998 by Gerald Combs. In 2006, the name was changed to Wireshark to avoid copyright issues, and it has been under constant development ever since. It is completely open source under the GNU General Public License, or GPL. Wireshark can be used to capture, and our network allows you to potentially intercept and decode any unencrypted packets that allows members of the Wireshark group to do so. You'll start seeing all of the network packets sent and received. There's still quite a few of them, but after scrolling through, I should be able to find the ones I'm looking for. Here, I've selected the first packet I sent, which is a standard DNS query for people.cs.ksu.edu. Ethernet protocol info in the transport layer. For example, here the Dynamic Host Configuration Protocol, or DHCP, is a core part of operating any network today. This video will introduce DHCP and demonstrate how it works. In your list, there were many networks that existed across the world, but they were not interconnected. In 1982, the TCP and IP protocols were developed with the aim of unifying all of those networks into a grand interconnected network, or were getting larger and larger, and manual configuration of those networks was simply too difficult to manage. In addition, with the introduction of laptops and mobile devices, computers needed to be able to seamlessly move from network to network without needing additional configuration. So, they really needed a method to automatically configure network settings on a computer when it initially connected to a network, hence the creation of DHCP. Beyond that, there are many features built into DHCP that make it a very DHCP server can reuse IP addresses once the leases have expired. In addition to IP addresses, modern DHCP servers can also send additional information about the network, such as DNS servers, SMTP servers, and more. Using DHCP, modern computers can be much more portable, allowing them to seamlessly connect to any network providing a DHCP server. Finally, even though DHCP is very powerful, this allows the college message. You can have multiple DHCP servers available on the network, good for 10 minutes, but clients can request a lease as long as 2 hours, 120 minutes, or 7,200 seconds. Below that, we can see some default settings for the network, giving the domain using that configuration. Our Wireshark so we can capture these packets. I'll also add a filter for the BootP protocol to make sure we only see the DHCP server packets. Since BootP and DHCP are compatible protocols, this is the way that Wireshark would see the packets. Next, I'm going to boot up the client, which will cause it to request an IP address as it boots. Once it is booted and I've logged in, I'm also going to release my IP address using the command sudo dhclient-r-v. This should send a DHCP release packet to my DHCP image and the original handshake. By default, the DHCP server will log information to the system log, so we can find it helpful to review. The Domain Name System, or DNS, is another integral part of working with the internet and larger networks today. In this video, we'll cover the history of DNS, how it works, and how to use it in an enterprise organization using the Bind software. As a quick note, much of the information in this lecture is adapted from information provided by Seth Gallitzer, our system administrator here in K-State CS. He created the original slides as part of a guest lecture in this course when it was offered on campus, and was gracious enough to share this information for future versions of the course. First, let's review some quick history. As you may know, the precursor to today's internet, the ARPANET, was first conceived in 1965. By 1969, the first 4 nodes of that network were connected. Over the next 2 decades, ARPANET slowly grew in size, and by 1982, with the introduction of TCP and IP, it exploded in size as various networks joined together to create the internet we know today. In the early days, they found it would be helpful to have a list of human-readable names for the nodes on the network. In that way, instead of remembering the IP address of a particular server, you could just remember its name and look up the IP address, much like you would look up the phone number of a person or business using the phone book. So they created a file called hosts.txt, which was hosted by the Stanford Research Institute. In essence, it contained a list of all the servers on ARPANET paired with its IP address. Anyone could query that file with a computer name and get back the IP address of that system. While it was a useful system, it had some major drawbacks. First, it must be updated manually. At one time, the only way to add a new system to the file was to contact the person in charge of it via telephone. As the file grew larger, it was more and more difficult to maintain consistency and avoid name collisions. Finally, it became very taxing on SRI's system, as each system on the growing internet would download a copy of the host's file to store locally, sometimes requesting it many times per day to get the latest version of the file. So, a new system needed to be built to provide this feature. In 1983, the first version of the Domain Name Service, or DNS, was published as an RFC. It was later finalized in 1987. They proposed creating a distributed system of name servers, as well as a hierarchical, consistent namespace for all the systems on the internet. Beyond just working with domain names and IP addresses, they also added the ability for the system to work with many different protocols and data types, hopefully designing it in such a way that it would work well into the future. Thankfully, their design was very successful, and we still use it today. The domain namespace we use today has a hierarchical format, much like this diagram. At the very top of the diagram is the root name server. It is responsible for keeping track of all the locations of DNS servers for all top-level domains, or TLDs, in the current domain name space. The original DNS specification calls for 13 root name servers, which is still true today. However, due to advances in technology, there are nearly 1,000 redundant remote name servers on the internet today, each one a clone of one of the 13 original root name servers. The file containing information for all of the top-level domains is very small, only about 2 megabytes, and can be viewed by following the link in the resources section below this video. Below the root name server is the name server for each chosen top-level domain. For example, these are the name servers for the .com, .org, and .edu, and other top-level domains. Under each top-level domain are the name servers for each individual domain name, such as yahoo.com, /.org, or kstate.edu. Within each domain, there can be additional levels of delegation, such as the cs.kstate.edu subzone, maintained within the K-State CS department for our own internal systems. With the hierarchical design of the domain namespace, it may take a few steps to determine the appropriate IP address for a given domain name. For example, if you want to find the IP address of www.wikipedia.org, you might first start by querying the root name server for the location of the .org name server. Then, the .org name server can tell you where the wikipedia.org name server is. Finally, when you ask the wikipedia.org name server where www.wikipedia.org is located, it will be able to tell you that since it is the authoritative name server for that domain. In practice, often there is caching DNS servers hosted by your ISP that store previously requested domain names, so you won't have to talk directly with the root name server. This helps reduce the overall load across the root servers and makes many queries much faster. The most commonly used DNS software today is Bind. Bind was originally developed in the 1980s as the first software to fully implement the new DNS standard, and it has been under constant development ever since. The latest version of Bind is Bind 9, which was released in 2000, but it still consistently gets updates even today. The DNS specification includes many different types of records. The most commonly used ones are listed here. For example, an A record is used to list a specific IPv4 address for a hostname, whereas a CNAME record is used to provide an alias for another domain name. For this lab assignment, you'll be configuring a DNS server using Bind within your network and using several of these record types, so we'll take a look here at how that works. Here I have created an Ubuntu VM as directed in Lab 3 to act as a DHCP and DNS server. I also have a second Ubuntu VM acting as our client. Finally, I've disabled the DHCP server in VMware on this particular network segment. First, on my server, I'm going to start Wireshark so we can capture these packets. I'm also going to add a filter for DNS to make sure that we only see the DNS server packets. On the client, I've already verified that it is configured to use the other Ubuntu VM as a DNS server. You can see the currently configured DNS servers using the following command. Here we can see that the DNS server is .40.41, which is the IP address of the Ubuntu server. When this output is open, you'll have to press the Q button to close the output. Next, we can query a DNS record using the dig command. For example, I can use the dig command to look up ns.cis527.cs.ksu.edu, one of the servers we will create for Lab 3. Looking at the output received, we can see that we did indeed get the correct IP address for that server in this answer section right here. We can also run that command for win.cis527 and ubu.cis527 to find the entries for those entries as well. Let's do that second one. Here, you'll note that the output for this one includes a CNAME record, redirecting it to ns.cis527, along with the A record for that server. To perform a reverse lookup, we can use the dig-x command and provide it an IP address. Since my sample network is using the 192.168.40.0 subnet, I could look up this IP address. Here, you'll notice that it returns a PTR or pointer record associated with that IP and returns the domain name that's assigned to it. I could do the same for any other IP that is assigned in that DNS server, from both forward and reverse DNS lookups. Back on the server VM, we should clearly be able to see the DNS packets in Wireshark. Each one gives the type of record requested, and just below that is the response packet with the answer from the DNS server. And here is information you should this process can definitely to ask for help. There's so much new information to read and understand. Don't be afraid. In the next few videos, we'll take a look at some other important networking protocols that you may come across as a system administrator. The first one we'll review is the Simple Network Management Protocol, or SNMP. It was first developed in 1988 as a way for system administrators to query information from a variety of devices on a network and possibly even update that information as needed. Remember that primarily used for significant revision to SNMP v1 and includes a much more use the older protocol data units, or PDUs, as part of the standard base, or MIB, to be difficult to read directly since each level of the hierarchy is denoted by a number instead of a name. To help make the variables more readable, SNMP includes a management information base, or MIB, to define what each variable means. Each individual device can define its own MIB, though there are some standards available for common types of data. You can find a couple of those standards linked below this video. The SNMP protocol itself lists many different types of protocol data units, or PDUs, as part of the standard. For example, the GetRequest PDU is used to query a particular variable on a device, and the response PDU would be sent back from that device. You'll be able to see several of these PDUs a bit later in this video when we use Wireshark to capture some SNMP packets. As mentioned earlier, one feature of SNMP is the use of a community string for authentication. In SNMP version 1, the community string was a simple text identifier that you can provide since I'll be accessing it from query a single variable. To see all of the available SNMP variables on our system, we can use the following command. The SNMP wouldn't have to request Okay, so I'm going to try and talk through a model solution version of Lab 3 and give you some advice on how to go about this lab and also how to verify that you got this lab configured and working properly. So the first thing we're going to do is we're going to look at our IP address. So I'm going to go to the Edit menu in VMware and then choose Virtual Network Editor. And in the Virtual Network Editor, we're going to find our NAT network, and we'll notice that it has a subnet address of 192.168.40.0. Yours will probably be similar, but it may have a different third octet right here. It's usually randomly assigned by VMware when you install it. Mine is .40, yours might be different. So we need to make note of that IP address. The other thing in here we can see is this check mark, the use local DHCP service. Once you get done with task 4 and have your DHCP server running, you'll want to go in here and uncheck this box. You have to click this change settings button to give it admin access, but then you can uncheck this box to turn off VMware's DHCP service so you can use your own. So remember, we have 192.168.40. So up here in Ubuntu, we want to set a static IP address in that same range. So in my settings, if I go in here and look at IPv4, you can notice that I've set an IP address 192.168.40.41. And the .41 is what the assignment says that we're going to use for our Ubuntu server. We also need to set the gateway. In VMware, it uses a default gateway of .2 inside of your network. The reason it does this is .1 is usually used by your home routers and some other services. And so to avoid any conflicts, VMware has set it to .2. We also have the netmask of 255.255.255.0. That's pretty standard. We talked about that in the lecture. And then you notice that right now I've actually set it to refer to itself as a DNS server. Originally in the lab, you'll probably set this to .2 so that you still have working internet, but once you get your DNS server working, you can set it to .41 so that it actually refers to itself for its DNS. So we'll go ahead and apply this. Once you apply it, you can turn it off and turn it back on to make sure it's applied. This is the only VM in this lab that you need to set a static IP address on. I've seen some students try and set static IPs on the Ubuntu and the Windows. You don't need to do that. For testing of your DNS server, you can set a static DNS entry temporarily, but the idea is by the time you get done with Lab 4, these two, your Ubuntu client and your Windows client, should both be getting its IP address from the DHCP server on your Ubuntu server. Okay, so once we have that set, we can confirm our IP address is correct by doing IP-addr show. That will show us our IP address. And we'll notice right here that we see the 40.41 IP address. We also need to keep in mind this ENS33. This is the name of the interface that this is connected on. And so in the DHCP setup, you'll need to go in and set a file that defines which interfaces to listen on. This is the interface we want to listen on, but for the DNS server, we actually tell it the IP address that we want to listen on. And so we'll need this IP address in our DNS server configuration. So once we have our DNS server up and running, we'll also need to make sure that we allow it through the firewall. I'll leave that up to you. You can look up what ports you need and how to allow that through the firewall. But if it's working, we can use the dig command followed by an @ symbol and the IP address of our system. And so what this does is this tells dig to ignore any DNS settings we have on our system and query this particular server. And we're going to query for ns cs527rusfeld.cs.ks.edu. And when we do that, we get this response. Here, just to help, let me put this command back up here again. So I'm doing dig at the IP address of my server, and you can do this either on the server or on the clients, and then I'm giving it the name of a server that I want to look up in our DNS configuration. And so if I run this command in this answer section, I should get back that this name goes to this IP address, which is correct. So that's how we look up an entry in our forward zone. If we want to look up an entry in our reverse zone, instead of doing to this to look up in our DNS configuration. And so if I run this command in this answer sequence, and I'm giving it the name of a server that I want to look up in our DNS configuration. And so if I run this command in this this answer section, I should get back that this name goes to this IP address, which is correct. So that's how we look up an entry in our forward zone. If we want to look up an entry in our reverse zone, instead of doing the name, we do .x, and then we would put in an IP address. I'm going to put in the IP address 42, which when we do this, it will show our answer section is we're looking up 42.40.168.192.inaddr.arpa, which is the reverse lookup IP address, and then we are getting our Windows server back. So to really check to see if your DNS server is working, those are the two commands you need. You just need to be able to use dig at your server's IP address and then -x for reverse lookup, or for a forward lookup, you just put in a domain name. You can also test your forwarding. If you want to make sure your forwarding is working, I can dig that server and just look for www.yahoo.com, for example, and I can get responses from that. I can also look up the reverse. If I want to look up a reverse, I can do a reverse for 208.67.222.222, which is one of the OpenDNS resolvers. So this is pretty much confirmed that our DNS server is working on the server. If you want to check it from one of your clients, you can switch over to your clients, and here on the client, I can run those exact same commands. So if I do dig at my server IP address, and this is without setting any static DNS entries, this is just telling dig to query this IP, and then if I do my address here, then I can run it, and once again, we're getting that answer. And so this is how you can test your DNS configuration before you have DHCP working. You don't have to change anything on your client. You just use the @ symbol in your dig command to tell it to query that particular DNS server for this entry. So that's the DNS parts. If that doesn't work, there's a really good guide on DNS troubleshooting that talks you through a lot of different things you might run into. Be especially careful of your periods and your spacing and your DNS configuration files. All of that is really important. There's also a really good discussion on Piazza right now about the number of octets in your reverse zone file. In the .local file, you can have 3 octets, and then you only need 1 octet in your zone file. If that doesn't make sense, post on Piazza, let us know. We can try and clarify that. Okay, so the second part is your DHCP server, and the DHCP server configuration is pretty simple. However, I'm going to call out one thing real quick. If I go to /etc/default, you'll notice there's a file in here that might exist that's, whoops. Oh, so I go to the server. If I go to the server and then look in here, you'll see there is a file called ISC DHCP server. And so in this file, it has some entries, and depending on what guide you read, sometimes you will need to define an interface right here that your DHCP server could listen on. Mine, I didn't need to define that, it just worked, but in a lot of cases you might need to define that. So this is where you would put that ENS33 that we saw earlier. So once you get your DHCP server running, you can start it. I'm just going to restart mine. So I restart that, and now your server should be running. If you want to check, a good way to check is you can do sudo cat
Why is it on automatic? Why did this get changed? Oh, that's not good. Here we go. Why can't I turn this off? Automatic. Why is that not saving? Why? It's not working. Why is this not saving? Manual. Why did this get... Bro, what is happening? 172.16.62. Apply. Okay. That's no good. It's gotta has to do something like VMware.
For ask here, is connected to, and in let's select. To view the virtual networks in VMware Workstation, click the Edit menu, then choose the Virtual Network Editor. On VMware Fusion, you can find this by going to the VMware Fusion menu, selecting Preferences, then the Network option. Here we can see the virtual networks available on your system. Right now there are two networks on my system, one host-only network and one NAT network. For this lab, we'll be working with the NAT network, so let's select it. First, let's look at the network type listed here. For this module, it is very important to confirm that the network type is set to NAT and not bridged. If you use a bridged network for this lab, you could easily break the network that your host computer is connected to, and in the worst case, earn yourself a visit from K-State IT staff as they try to diagnose the problem. So make sure it is set correctly here. We can also see lots of information about the network settings. For example, we can see the subnet IP here and the subnet mask here. By clicking on the NAT settings button, I can also find the gateway IP. The gateway IP is the IP of the router, which tells your system where to
Oh, that's because, okay, I see. I have a VMware acting as a DHCP server. So I need to disable that. So I missed that step.
Direct outgoing internet traffic. You'll want to make a note of all three of these, as we'll need them later to set a static IP in Ubuntu. You can also click the DHCP settings button to view the settings for the DHCP server, including the range of IP addresses it uses, which can also be very helpful. If you want to change any of these settings, you can click the Change Settings button at the bottom. You'll need administrator privileges to make any changes. Next, let's confirm that our VM is using that virtual network. To do so, click the VM menu, then select Settings, then choose the Network Adapter option. Make sure the network connection is set to NAT here as well. Click the VM menu. You'll need administrator privileges to make any changes. Next, let's confirm that our VM is using that virtual network. To do so, click the VM menu, then select Settings, then choose the Network Adapter option. Make sure the network connection is set to NAT here as well. Okay, now let's take a look at the network configuration in Ubuntu. In this video, I'll discuss how to view and update the networking settings using the GUI. There are, of course, many ways to edit configuration files on the terminal to accomplish these tasks as well. However, I found that the desktop version of Ubuntu works best if you stick with the GUI tools. You can access the network settings by clicking the Activities button and searching for Settings, then selecting the networking option on that window. As with Windows, once in the Settings menu, click the gear icon next to the connection you'd like to tab. Here, you can choose to input a manual IP address. If I select that option, I'll have to enter an IP address, subnet mask, and default gateway. For the IP address, I'll just make sure that it isn't in use on the network by picking one outside the DHCP range used by VMware. The subnet mask and default gateway should be the same as the ones you found in the VMware network settings earlier. Finally, we'll need to enter some DNS servers. Typically, you can just enter the same IP address as your default gateway, as most routers can also act as DNS resolvers as well. You can also use other DNS servers, such as those from OpenDNS or Google, as described in the Lab 3 assignment. Once you've made your changes, click the green Apply button in the upper right corner to apply your changes. If everything is successful, I should still be able to access the internet. Let's open a web browser just to be sure. Ubuntu includes a number of tools to help troubleshoot and diagnose issues with your network connections. Most of these are accessed via the command line. So let's open the terminal window. First, you can view the available network devices using the networkctl command. You can also view their status using networkctl status. If you've worked with Linux in the past, you're probably familiar with the ifconfig command. However, in recent years, it has been replaced with the new IP command, and Ubuntu 18.04 is the first LTS version of Ubuntu that doesn't include ifconfig by default. So we'll be using the newer commands in this course. The first command to use is the IP address show command. This command will show quite a bit of information about each network adapter on your system, including the IP address, which is right here. /var/log. Okay, so once it does this is .1 is we're going to find our NAT. Okay, so I'm going to try and talk through a model solution version of Lab 3 and give you some advice on how to go about this lab and also how to verify that you got this lab configured and working properly. So the first thing we're going to do is we're going to look at our IP address. So I'm going to go to the Edit menu in VMware and then choose Virtual Network Editor. And in the Virtual Network Editor, we're going to find our NAT network, and we'll notice that it has a subnet address of 192.168.40.0. Yours will probably be similar, but it may have a different third octet right here. It's usually randomly assigned by VMware when you install it. Mine is .40, yours might be different. So we need to make note of that IP address. The other thing in here we can see is this check mark, the Use Local DHCP Service. Once you get done with task 4 and have your DHCP server running, you want to go in here and uncheck this box. You have to click this Change Settings button to give it admin access, but then you can uncheck this box to turn off VMware's DHCP service so you can use your own. So remember, we have 192.168.40. So up here in Ubuntu, we want to set a static IP address in that same range. So in my settings, if I go in here and look at IPv4, you can notice that I've set an IP address 192.168.40.41. And the .41 is what the assignment says that we're going to use for our Ubuntu server. We also need to set the gateway. In VMware, it uses a default gateway of .2 inside of your network. The reason it does this is .1 is usually used by your home routers and some other services. And so to avoid any conflicts, VMware has set it to .2. We also have the netmask of 255.255.255.0. That's pretty standard. We talked about that in the lecture. And then you notice that right now I've actually set it to refer to itself as a DNS server. Originally in the lab, you'll probably set this to .2 so that you still have working internet. But once you get your DNS server working, you can set it to .41 so that it actually refers to itself for its DNS. So we'll go ahead and apply this. Once you apply it, you can turn it off and turn it back on to make sure it's applied. This is the only VM in this lab that you need to set a static IP address on. I've seen some students try and set static IPs on the Ubuntu and the Windows. You don't need to do that. For testing of your DNS server, you can set a static DNS entry temporarily, but the idea is by the time you get done with lab 4, these two, your Ubuntu client and your Windows client, should both be getting its IP address from the DHCP server on your Ubuntu server. Okay, so once we have that set, we can confirm our IP address is correct by doing IP-addr show. That will show us our IP address, and we'll notice right here
Bro, it's an absolute pain trying to manage these virtual machines. Is it easier on Windows? Is this just like a Mac thing where everything is like it's a separate window and like the window I don't know what to do. Honestly, is the question. I wish it could just have like a single window, and then within the virtual machine manager I can just have like a window inside that. Like, I wish I could just use it in here. You know what I'm saying? And then have each one of these just usable in here, so that way this window can stay the same. Is that a thing that I can do? Tab bar? What is this? I'm just gonna ask AI. I have a window man. It's probably just gonna have them floating is probably gonna be the solution. Is just to float them. I want each VM to open in a single window with tabs instead of their own windows. I don't even think that's a thing. Yeah, VMware and Windows uses a tab interface. Bro, this is the most annoying thing ever. Are you kidding me? Each one in its own separate window. Why? Bruh. Oh. It just makes it so annoying. And I can't even use this. What is even the point of this? Okay, that sucks. Back to what I was doing. I'm just gonna have to completely float everything, honestly. Is that gonna be the solution? I think that's the solution. I don't know how to fix this. I don't know what to do with this. It keeps getting reset. Like, it literally does not allow manual setting of this. Apply. Okay, now it's manual. But if I restart this, it's gonna reset. So I think I have to just keep going and then turn off the DHCP, and then it should stay. So that's what I'm gonna do. I'm gonna hope that's the solution, so I'm just gonna keep going. Where was I? Now I'm here. Wait, no, now I'm here. Let's see, I did the conf.options. Now I need to do named.conf.local. Okay, what do I need to add in here? Specify your forward and reverse zones. DNS zones designate a specific scope for managing and defining DNS records. Since this guide's example domains will all be within this subdomain, we will use that as our forward zone. So I'm just use my own here. I don't need the allow transfer directive though, so I just need to do what is happening? Let me just double check the assignment. Where is it? Here. Create a zone file and reverse zone file stored in here. For your VM network, you're most likely using this, yes. I think I'm fine. Or do I have to use... Do I use this or do I use this? Conf.local, create a zone file. Zone files, use this as your FQDN. Okay, I'll just use this. So I think it's gonna be this. I think it's just gonna be that. I don't know. I have no idea, honestly. I don't need to do the allow transfer at all. So I just use this. Use this as your FQDN in your config file, okay. I'm just gonna keep going. Now I gotta do the reverse. Which is this is not fun, I'm not gonna lie. This is not, I don't know what's happening, but I'm going with it. Oh, I don't need, that's it. That's all I need, okay. And then I don't need the allow transfer, okay. Okay, let me just double check. Oh, I did not do that, correct. Okay, I think that's right. If your servers spend multiple private subnets in the same, no, I don't. Okay. I don't know what this zone files. Creating zone file and reverse zone file stored in here. Okay. Wait, let's see bind zones. Let's see bind zones. Yes. Okay. This was for this. Being very scrutinous of this config file. I don't want to mess anything up because it's going to cause headaches. They use a /16, but I'm using /24. Okay, I think this is all good. Let's just... Okay, let's keep it going. Now we got to do the zone files, which is this section. Yeah, so we want to make sure we have the IP to a FQDN and also an FQDN to an IP. So that's what we're setting up. Okay, so now we have to actually create this directory. Okay. that's already here. I could just do /zones, but I want to make sure. Yeah, I'm already in that directory, but that's fine. /zones. We will base our example forward zone file on the sample db.local zone file. Copy it to the proper location with the following commands. Okay. Let me just make sure it wants me to do that. Oh, I think this is referring to this. Wait. If this is like jumping around forward zone file? I did this fine. Okay, this is the zone files that I'm doing now. Yeah, okay, I think I'm gonna get to this. Let me just keep going. Copy /etc/bind/db.local. /zones/db dot should be affirm24.cis527.org. Okay. Nope. Okay. That's not even a thing. I don't even know. I don't even have that. What are these people talking about? I don't even have that. Why don't I have that? I'm just gonna manually type this out. I guess I'm gonna manually type it out. This is gonna suck. Is that a space or there's a space? Why is that a space right there? No, that's a tab. No? I have no idea. I have no idea what's going on. Oh, this is so bad. There's no, is it gonna work if I copy? I don't think it will. Ooh, it will. Never mind, we're good. I don't know how to delete all this. I'm sorry, I have no idea. Bam. Oh, we're in it. We're in it now. Okay. We need to delete this anyway, so that's fine. I don't know what it's doing. You want to edit SOA record. Replace the first localhost with NS1's FQDN. Oh, this one. Okay. Now we can go to here. Okay, this says use this as your FQDN in your config file. Okay. What about this root? Then replace root with admin.this. Okay. Everything is fine so far. Serial is this. Okay. Wait, every time you edit a zone file? Oh, okay, so I edit it, so then change it to 3? Okay, I don't get it, but I'll do that. Okay. 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 Next, delete the 3 records. Okay, I did that. Do I add it here? Or do I do it like this? I don't know what character that is, or if I need it. Oh, it's just a regular dash, okay. Does the spacing not matter? I don't understand. Pretty sure that's what I need. Let me see. Use NS as your authoritative name server for the contact. Okay. I need to end with the dot. Wait, what about these? Oh, these also need to be a dot. Okay. A records. Don't forget to increment the serial each time you edit the file. Okay. Create NS record for NS this. Okay. At the end of this record, like this. Okay. I don't know. Okay. This is terrible. I hate DNS. Okay, now I think actually what I can do is this. What was the first one? NS1. Create an A record for your NS1 that points to the server. Okay. NS this 2.16.62.41. This will be the AD Active Directory for the next lab. Wait, name server, hold on. Yeah, this should just be here, okay, and that should just be, so the AD would be in a separate section, A record. Oh, this is a comment. This is a comment. Okay, I understand. So this is just, okay. That's why this is, okay. I see. So this would be AD servers dash A. That's just for labeling. So I think I should be fine with doing what I'm doing. Like this. And then putting ad.a from 24.cis 527.org dot tabbing I don't think is gonna matter. This setting it up as for 2. Now we can do the network, which is this 24A records, and whatever else is here, which I think is just the... Oh, there's gonna be 2 clients probably, because they're probably gonna clone another Windows machine, but I don't know. Let's see. Create a C name. Oh, I don't need an A record for anything else? That's it? Do I not need the other ones? What about my Ubuntu client? Yeah, what about hosts? What if I want to make this like Ubuntu? I'm pretty sure I can do that. And this would be, or actually I'm not going to be assigning a thing here. So maybe not. It's not going to have a static IP. Okay, I'm not going to do that. I'm just going to ignore that. It should be fine without it. But it does want C names. Oh, here, Ubuntu. Oh no, this is going to just redirect to the name server. Okay. This will be for the other file. Okay, C names. Let's see, C name. Name servers, this, save and close. Now now I need to do C name, so I'm assuming it's going to be the same thing as this, just, let's see, aliases, and then do C name records. Should I do that? I think so. This one is not going through any C names. Oh, I guess it doesn't matter what I name that. I think that's a comment, I'm pretty sure. So I'm just gonna do this. I'm gonna do Ubuntu dot. Pretty sure it's just gonna be like that, and then this will direct to the name server. That's just an alias for this. And then this one, let's see, another one, LDAP. And that's going to point to also the name server. Does it need a period at the end or not? Hint, the periods, semicolons, and white spaces in DNS config files are very important. And white space. Oh no, that's no good. Be very careful about formatting, including trailing periods after full DNS names. Oh. Okay. Oops. Do not want to forget anything because it's going to be a pain to troubleshoot. What the? Okay. Okay, I'm hoping this is okay. 80 servers names. I think this is just a comment, but I have no idea. Look, this is the end of this, so this should be fine here like that, but I have no idea. I guess I'll find out later. Okay, now one more. Windows. This one's going to be the AD dot. Okay. Is that it? I think that's it. Saving. Now we gotta make another one. The reverse. There we go. I think we're good. I think we're good so far. Another one. Let's do another one. Now we're gonna do... What is happening? Where did I click? Zones slash... And this one's gonna be called... db dot let's see. I think I just need to include everything except for the in ARPA. Just do the beginning of this. So that's what I'm gonna do. Why does it go from 1 to 3? I don't know. I'm gonna do 3 though. I have no idea. Do I edit here? I have no idea. Or do I leave at least one line? If it doesn't work, I'll try to remember to do this. I feel like something's not right here. What do I do here? Create a pointer record. I need these first and then pointer records. Okay. I don't know why the instructions are not saying to do this, but I'm just gonna do what this one is saying. Now I can do pointer records. And let's see. Need to do this for NS and this for the AD, okay? So just the ending? Just the ending. 41 pointer and if you had 2 name servers, then you just do each line like twice with NS1 and NS2, but I'm not doing that. So that's simple enough. And then I can add a comment here, space. This is going to be 62.41. Okay, and this is going to be 42. Just going to do space. .42, and that's going to be for the Active Directory server. .41 for this, 42 for this. Periods at the end? Yes. Okay. Typos will be the bane of everyone, so you always have to be, typos will get you. So one day I'm not even gonna go into it, but one time I wasted like 3 days trying to troubleshoot just to realize I needed to quit and restart. 3 days. Unreal. Okay, I think that's it. Okay, so now I can run check configuration using named-checkconf. Is that a command? Here we go. What is all this? Before zone. So line 10 and line 11 before include. Okay, so that's gonna help. So that basically just verifies my conf file. So let me do named.conf.local. Line 10. There's nothing even here. What could be wrong about this? Line 11 missing that before include. Line 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You want this? That's what you want? Oops. You want that? That's what you want? But I didn't even edit those fields. Those are just completely normal. Oh, I need to... Oh, the second argument to this... Okay, I'm silly. I'm retarded. Okay, hold on. I need to do check conf, and then what's my conf file? Named.conf? Which one did I edit? I think I did options. Named.conf.options, named.conf.local. I don't know. Named-check conf named.conf.local. Okay. This before zone and this before end of file. Okay. I can do that. Okay, we got that fixed. Totally caught that typo. Okay, nice. Next one. I need to check the conf.options. Good, that one looks good. Okay. Now I need to check the zones. Named-check zones. .org. Is it a space? Oops. Bad name. Alright, I have some kind of issue I have to troubleshoot here. Line 9 warning. Okay, let me, Let me get rid of that. I think maybe that's causing problems. Loaded serial 3. Oh, I forgot to... change the edit this thing. Just, I don't know, maybe that doesn't make sense to do that. Loaded serial. It says okay. Okay, so that works. Now I need to do the other one. So I imagine this is reverse. So this. Okay. I ran the checks that said okay. You may need to update firewall to allow incoming DNS to the system.
Here that we see the 40.41 IP address. We also need to keep in mind this from the DHCP server on your Ubuntu server. Okay, so once we have that set, we can confirm VMware when you install it. Mine is .40, yours might be similar, but it'd be the edit menu in VMware and then choose virtual network editor. And in the virtual network editor, we're going to find our NAT network, and we'll notice that it has a subnet address of 192.168.40.0. Yours will probably be similar, but it may have a different third octet right here. It's usually randomly assigned by VMware when you install it. Mine is .40, yours might be different. So we need to make note of that IP address. The other thing in here we can see is this check mark, the use local DHCP service. Once you get in, so we can confirm our IP address back on to make sure it's applied, and with lab interface that this is connected on. And so in the X symbol and the IP address of our system, -X, and then we would put in an IP address. I'm going to put in the IP address 42. Which, when we do this, it will show our answer section is we're looking up 42.40.168.192.inaddr.arpa, which is the reverse lookup IP address, and then we are getting our Windows server back. So we would put in an IP address. I'm going to put in the IP address 42. Which, when we do this, it will show our answer section is we're looking up
This is not working at all for me. I don't know why. But what is wrong then? I don't understand what is wrong. have no idea what's wrong. So this is supposed to mean that something's wrong with my local file, but my local file's fine. Unless it's not, but I don't see what the issue is. Is there anything wrong here? Anything wrong here? Well, these people, they literally missed out on the at. So is there supposed to be an at here? And now I have to change this for. That's not working still. Hmm. What do you mean trailing dot? I have a trailing dot.
42.40.168.192.inadder.arpa, which is the reverse lookup IP address, and then we are getting our Windows server back. So to really check to see if your DNS server is working, those are the two commands you need. You just need to be able to use dig at your server's IP address and then -x for reverse lookup, or for a forward lookup, you just put in a domain name. You can also test your forwarding. If you want to make sure your forwarding is working, I can dig that server and just look for www.yahoo.com, for example, and I can get responses from that. I can also look up the reverse. If I want to look up a reverse, I can do a reverse for 208.67.222.222, which is one of the open DNS resolvers. So this is pretty much confirmed that our DNS server is working on the server. If you want to check it from one of your clients, you can switch over to your clients, and here on the client, I can run those exact same commands. So if I do dig at my server IP address, and this is without setting any static DNS entries, this is just telling dig to query this IP, and then if I do my address here, then I can run it, and once again, we're getting that answer. And so this is how you can test your DNS configuration before you have DHCP working. You don't have to change anything on your client. You just use the @ symbol in your dig command to tell it to query that particular DNS server for this entry. So that's the DNS parts. If that doesn't work, there's a really good guide on DNS troubleshooting that talks you through a lot of different things you might run into. Be especially careful of your periods and your spacing and your DNS configuration files. All of that is really important. There's also a really good discussion on Piazza right now about the number of octets in your reverse zone file. In the .local file, you can have 3 octets, and then you only need 1 octet in your zone file. If that doesn't make sense, post on Piazza, let us know. We can try and clarify that. Okay, so the second part is your DHCP server, and the DHCP server configuration is pretty simple. However, I'm going to call out one thing real quick. If I go to /etc/default, you'll notice there's a file in here that might exist that's, helps if I go to the server. If I go to the server, and then looking here, you'll see there is a file called ISC DHCP server. And so in this file, it has some entries, and depending on what guide you read, sometimes you will need to define an interface right here that your DHCP server could listen on. Mine, I didn't need to define that, it just worked, but in a lot of cases you might need to define that. So this is where you would put that ENS33 that we saw earlier. So once you get your DHCP server running, you can start it. I'm just going to restart mine. So I restart that, and now your server should be running. If you want to check, a good way to check is you can do sudo cat /var/log syslog, and we'll look at the very end of our syslog, these last few entries, and we can see here that our DHCPD server started up, it read its config file, and then it will say things like listening and sending. And as long as you see that it's listening on ENS33, that means it's working. If you get an error here that says it's not configured to listen on any interfaces, that's where you might need to change that defaults file to listen on ENS33. You get an error here, big file, and we'll look, and now your server should be running. If you want to check, a good way to check is you can do sudo cat /var/log syslog, And we'll look at the very end of our syslog, these last few entries, and we can see here that our DHCPD server started up, it read its config file, and then it will say things like listening and sending. And as long as you see that it's listening on ENS33, that means it's working. If you get an error here that says it's not configured to listen on any interfaces, that's where you might need to change that defaults file to listen on ENS33. To work. So that's how you can tell your DHCP server started correctly. There's a couple other commands that you can use using the SS command to look at listening ports. So SS-L will show you all the listening ports on your system. However, it's not very useful at all. So instead we can try two different versions. I'm going to do SS-L, then I'm going to do T, which will listen for TCP ports only, and then in, which will show us the port numbers. So if I do SS-LT in, I will see really quickly that I have a DNS server listening right here on port 53. That's what we're looking for DNS. DHCP, however, is not TCP, it is UDP. And so if I look for UDP, I'll see a DHCP server listening here on every IP address on port 67. And so there is the entry for your DHCP server. And so if you're not sure if your servers are running correctly, you can use ss-l-tn or ss-lun and look for entries that end in 53 for your DNS server or 67 for your DHCP server. You'll also notice that there is 161 for your SNMP server if you have that running. So this is kind of a really useful thing. You can also see your SSH server running on 22222, and we'll see our HTTP server Apache running on port 80. So a couple of quick commands, but the really easy way to test your DHCP server is actually on Windows. And so on Windows, I have no static IP address set. If I do ipconfig/release, that will release all of our IP configurations. And then I can do ipconfig/renew to force it to renew that IP address. And so it will think for just a minute, and then it will come back, and it should give us an IP address that has something within our range. It has .2 as the gateway, but the big giveaway is you can find this connection-specific DNS suffix, and it will contain your EID. That's the dead giveaway that you are getting a DHCP address from your DHCP server, and that's why it's actually really easy to test this on Windows. Now, if I do ipconfig all, then it will show all the information, and you can see that it also is getting the DNS server for your network. And so it actually gets the right DNS server. It will also show you what your DHCP server is. So if you want to know where that IP address came from, you can find it here as well. And then of course, we can use NSLOOKUP to look up different names on our network. So if I do NSLOOKUP, I can look that up. And if I do the reverse, I can get the reverse as well. So everything is looking really good here. The other thing you can do obviously for testing is on your Ubuntu client, you can do sudo dhclient-r, which will run the DHCP client and refresh. If I do -r, sudo dhclient-v, you'll actually see it sending the DHCP discover. So it sends a discover, then we get an offer of this IP address from our server IP, and you can see that it works. So those are a quick overview of what Lab 3 should look like when it's working correctly. The big things to do are get your DNS server up and running and then test it here on your server using those dig commands with the @ symbol on them. So if we go back through my history, we find some of these dig commands having the @ symbol where we can query a particular DNS server and look up a particular address. Once you get that working, you can then test it from your client using that same syntax, or you can just go ahead, get your DHCP server up and running, check the system log to make sure it's running, and then go to your Windows client, reboot it, and make sure that it's getting an IP address from your system, and then you should be good to go. If it's not working, check your config files, check your firewall, make sure that it's listening on the right ports, or feel free to reach out on Piazza and let us know. So I hope this video is helpful.
That's always, that's always painful. That's always so painful when you're like going deep down this troubleshooting rabbit hole, and then you find out at the end that it was just a simple typo in something that you just should have checked right away. Oh, that's incredible. That's always so painful, so painful.
If you have suggestions and look up so if we go back through my history, we find some of these big commands having the @ symbol where we can query a particular DNS server and look up a particular address. Once you get that working, you can then test it from your client using that same syntax, or you can just log to make sure it's running, and then go to your Windows client, reboot it, and make sure that it's getting an IP address from your system, and then you should be good to go. If it's not working, check your config files, check your firewall, make sure that it's listening on the right ports, or feel free to reach out on Piazza and let